All right, today we're going to dive into the invisible world of the Internet of Things, IoT. And to really get our heads around how our world gets smarter every single day, we're going to follow a single piece of data on its, well, pretty epic journey, from the real world into the digital world and all the way back again.
I mean, you've probably wondered about this, right? How in the world does your thermostat know to kick on the heat just before you pull into the driveway? Or how does your fitness tracker just know you hit your step goal? Honestly, it feels like magic, but what's really happening is this beautifully choreographed digital dance.
At its very core, that's what the Internet of Things is all about. It's this massive, and I mean massive, network of physical things. We're talking everything from your car to your coffee maker that have been given a little bit of tech that lets them connect to the Internet. And more importantly, it lets them talk to each other and to us.
So, to really understand this, we're not just going to throw a bunch of facts at you. No, we're going on a trip. We're going to follow one tiny piece of data from the very second it's created to the moment it makes something happen in the real world. Think of it like we're exploring the digital nervous system of our planet.
Okay, let's get into it. What actually makes an object smart? It's not like there's some super genius AI living inside your light bulb. Nope. It's actually a really simple but incredibly powerful process. A loop that turns a little bit of information into a real-world action.
And here it is. This is our map for the whole journey. Just about every IoT interaction follows these 5 basic steps. First, it senses some information. Then it processes it. It communicates that out, somebody analyzes it, and finally it acts. We're going to walk through every single one of these to see how it all clicks together.
So our journey starts right here, right on the edge where the physical and digital worlds meet. This is the birthplace of our data. It's the moment an object gets its very first idea about the world around it. And that journey always begins with a sensor. The easiest way to think about a sensor is like the digital version of our own senses. A motion detector, that's kind of like its eyes. A microphone is like its ears, and a thermometer gives it a sense of touch. They're just constantly grabbing little bits of information from the world. And this brings up a really key distinction. So if sensors are the senses that are gathering information, then you have actuators, which are like the muscles that take action. So a sensor reads the temperature, an actuator turns on the AC. See the difference? One gathers, the other does. So the sensor picks something up, but before it just screams that information out to the entire internet, a little bit of thinking happens right there on the device itself. This is done on what's called an embedded system, basically a tiny, dedicated computer that acts like the device's local reflexes, making super quick, simple decisions on the spot.
Okay, so our piece of data has been born, and it's had its first little thought. Now it's time to leave the nest. This next stage is the Great Leap, where our data travels from its little isolated device out into the huge interconnected network.
Let's look back at our map. We've covered sensing and some local processing. Now we're at the absolute crucial third step, communication. This is where the smart object actually joins the internet part of the Internet of Things.
Now, for all these devices to talk to each other, they have to speak the same language, right? In the tech world, that language is called a protocol. You can just think of it as a set of rules. It's like grammar for machines. They make sure when one device sends a message, another one can actually understand what it's saying.
And here's the thing. There isn't just one language. There are tons of them, and each one is good for a different job. I mean, you wouldn't use a megaphone to whisper to a friend, right? It's the same idea. Wi-Fi is awesome for sending a lot of data really fast over a short distance, but man, it drains the battery. Bluetooth is great for low-power, close-up connections, and of course, cellular lets devices chat over huge distances.
So our little data packet has successfully made its way across the network. But where is it even going? Well, it's heading to this massive, centralized intelligence. It's going to the brain in the cloud, where its tiny piece of information gets combined with millions, even billions, of others to find some real meaning.
And this is so important. The data from your one smart thermostat? Yeah, it's useful for you, but it's not exactly revolutionary. But the data from 1 million thermostats all across the country? Whoa. Now that can predict energy demand, spot incoming weather patterns. That provides a world of insight.
And this, my friends, is where the cloud comes in. The cloud isn't some fluffy thing up in the sky. For IoT, it's the global brain. It's a gigantic network of super powerful computers that do all the heavy lifting, storing, processing, and analyzing all this data at a scale that is just impossible for any one device to handle. And that scale?
It is truly staggering. By 2030, experts project there will be over 29 billion connected IoT devices worldwide. Let that sink in. That's almost 4 devices for every single person on this planet, all chatting, all sending data to the cloud. Now you see why we need that massive global brain, right?
Okay, the cloud has done its thing, a decision has been made, and now our data's journey is about to come full circle. But this return trip is where we have to talk about something that's absolutely critical: security.
So we're back at our map for the last time, and we're landing on the final and maybe the most important step of all: act. The whole point of this entire journey, from sensing to analyzing, is to make something actually happen back in the real world.
So that command travels all the way back from the cloud, zipping through the network, right back to the original device. And it tells an actuator, our digital muscle, what to do. Turn on the light, unlock the door, adjust the thermostat. The loop is finally complete.
But, and this is a huge but, this seamless, powerful connection creates weak spots. Every single point in that data journey we just followed, from the sensor, across the network, up to the cloud, and all the way back down, is a potential door for someone to break in.
And these risks are very, very real. Data could be snatched right out of the air while it's traveling. A hacker could get access to your entire smart home network, or even worse, hijack a device completely. Imagine someone taking control of a connected car. Protecting this whole journey is one of the biggest challenges in the entire world of IoT.
And all of this leaves us with one final, gigantic question. This network is weaving itself into the very fabric of our lives, right? It's gathering unimaginable amounts of data about how we live, how we work, how we move. So as our world gets more and more connected, maybe the most important question isn't how it all works, but who should be in control.